Right, here we're into electricity and photonics. So I've got a circuit here, 10 volt battery, two resistors in series, and an ammeter here. What's the potential difference? Which means the voltage used, or the voltage drop, across R2. So what's the voltage over R2? There's two ways that we can do this that I'm going to go through. Way number one. Alright, so if we want to work out the voltage in R2, it's going to be helpful if we can work out the voltage in R2. It's going to be the current in R2 times the resistance in R2. We know the resistance, 30 ohms, but we don't know the current. So we need to work out the current first. And because this is just a simple series circuit, the current that goes through A is going to be the same that current goes through this one, R1, which is going to be the same current that goes through R2. So the total current we can work out is the same current everywhere. So we need to work out the total current. So V equals IR. I've put T in for total. And if I rearrange that to find the total current, we get V over R. Total voltage is 10. They're in series, so you add them up. 40 plus 30 is 70 ohms. And that equals 0.14 amps. Then with that we can now say that the voltage in 2 equals I in 2 times R in 2. That's the current through the whole thing is 0.14, and the resistance is 30. You times those together and you get 4.3 volts. Right, the second way of doing this is to do it as ratios. So they're in series, 10 volts gets shared amongst these. And then how does it get shared? Well, this has got more resistance, so it takes more of the voltage. The way you work it out, how it gets shared, is we want to work out the voltage over this. Is the voltage out, or the voltage you're measuring, is equal to the resistance you're measuring over the total resistance times the total voltage. So that's 30, because that's what we want to measure. Total is 70 times 10. And this is just what I was saying. As a ratio, this one gets 30 out of 70, or 3/7 of the total voltage. 30 out of 70, which equal to 3/7 of the total voltage. And the total voltage is 10. So this formula means ratio. And when you do that, you just times those in your calculator, you get your 4.3 volts. Alright. Next question, what's the power dissipated in R1? There's three power formulas that we have. P equals VI, P equals V squared over R, and the other one equals I squared R. We can use any of the formulas, because if we'd worked out this through way one, we've got the current, I, we could use that one or that one. If we hadn't worked out the current, we'd have to work it out to use these two, or we could use this one here. So I'm going to just assume we didn't have the current, assume we went through way two. But you can use any of these to find out what you need to know, as long as you use the right voltage, not 10 volts, the voltage over R1. So we have to work out the voltage over R1, and the easy way of doing it is the voltage in R1 is equal to the total minus your 4.3, which equals 5.7 volts. So any of the formulas, let's just use V squared over R. 5.7 squared over the resistance of it is 40, which gives 0.81 watts. Easy. Alright, new little diagram. I've added another resistor over to the side here. What's the current through this ammeter now? Same way as I did it in the first question. V equals IR. So for I make I the subject, I'm going to put little subscripts because I want to look at the totals. Total voltage over total resistance. Same total voltage, 10 volts, but what's the total resistance? But there's three resistors and two of them are in parallel, so it's going to be a little bit harder to work out. Question mark. So let's work out the total resistance of these two first. They're in parallel, so we're going to do 1 over. So we've got 1 over 40 plus 1 over 20. The common denominator here is 40, so you go 1 over 40 plus 2 over 40. I change that to 2 over 40, and that equals 3 over 40. It's not the total resistance, that's 1 over the total resistance. So I need to flip these around to get the total resistance in the parallel. 40 over 3, that equals 13.1 if you did 13.3 if you did that on your calculator. Now, that's just these two. We've got another one in series, so to find the overall total, we've got to add that in. So now we've got to say R total equals 13.3 plus, what's that other one? It is a 30 ohm. 43.3 ohms. Now we can go back into our formula we've got at the top. IT was equal to 10 over question mark, which we've now worked out. And doing that on your calculator, I get 0.23 amps.